the banks were like trying to get people to buy homes, and they were basically giving them without giving them the mortgages, the loans, or like, without checking, can they pay it back or not? They didn't have to put anything down. Like usually you have to put like maybe 20 or 30% of the money at the beginning, like that's your sort of guarantee that you're serious, right? But they said, no, you don't have to give any money down. Just do it, because they were getting what do you call it? Commissions. They were getting commissions by selling, right? The guys are going out and selling the houses. They're getting commissions, and they go to their bank friends and say, come on, just make it easy. And everybody was having a party, and so they did this. And then it turned out that, all this was built on a house of cards. It was all nonsense. But, when you're selling $1 billion worth of debt, you're not going to look at every single little mortgage, right? And try and figure out, this guy, doesn't have any money. How's he going to pay it back? And this guy, you got like 10,000 people in there. You're not going to look at it, right? Stockbrokers, investors and stuff, they don't look at that. They just say, oh, is it a good investment or not? They don't look at all the tiny, tiny details usually. So, anyway, it caused the whole world economy to crash, major crash, around 2008. So, anyway, but there are these people with Asperger syndrome, basically Asperger syndrome, which is the kind of, I don't know, maybe I don't really know about Asperger syndrome, but what is it? Let's see if there's any video about Asperger syndrome. Asperger's syndrome videos. Anything about it? So, anyway, it's a kind of autism, but so the people are kind of not socially really able to interact that well socially. But you'll find that like a lot of people who, they say there's a spectrum of autism. So you can have people that are super severely have autism, like kids that just can't talk to anybody and they're completely, and you can have people that don't have such severe autism. So, but you'll find like a lot of kind of programmers and stuff like that might be a little bit into the autism spectrum. They're not so good at. But people who have Asperger's, are very good at sort of concentrating on certain things, on details. They don't pay attention to people that much, but they're very good at paying attention to details and so on. So there were these people that sort of had Asperger's syndrome who started to read these mountains and mountains of mortgage files, right? And there were mountains of them, you can imagine like a book like this thick, of these details. And, these people like enjoy reading that, right? So they started to read all this and they said, wait a second, this is nonsense. And, nobody else believed them because nobody else thought that could happen, and they didn't want to read it themselves. So these people started buying options and futures on these mortgages or on this kind of debt. You know what options and futures are? So options and futures are, if you want to bet that the market is going to go up or down, you can do that with options and futures. So you can buy, it's beyond, I don't want to explain it, but it's not very complicated. But you can basically, bet that you think the market is going to go down instead of, normally if you invest in a stock, that means you think it's going up, right? And you wouldn't think that there's any way to, invest in the stock market with, hoping that it goes down. But you can, because basically it's just like a contract between two people one person thinks it's going to go up, the other person thinks it's going to go down. Those are called options and futures. And they're just different kinds of contracts that people make between each other. Okay, but they're kind of regulated, so it's not just, you can't just write something yourself. It's already written. But anyway, so you can bet that the market, so these guys started to buy huge amounts of whatever they were, futures or options or whatever, and hoping, thinking that the market was going to go down, and it did. And they became trillionaires, not really trillionaires, but they became billionaires, in a very short time, just because they were willing to read through these documents, right? So that's an amazing story. There's a great book written by somebody about these guys and about that. His name is Lewis something. Let's see if I can find it. Asperger syndrome, 2008. Crash. Who wrote this book? Did Asperger's help cause this crisis? Oh, what was that guy's name? I can't remember. Anyway, it's a great book about what happened. So if you're interested in reading it, it's supposed to be I didn't read it, but I've heard him speak. But it's supposed to be a really great book. Maybe we'll remember the name of it later. Anyway, so we were talking about what? Compound interest and this formula. I forget why I brought that up. Anyway, that's an interesting story. All right. All right. I said that when it involves money, people want to do all kinds of stuff, right? Because they think so. Like I said, so you wouldn't have, so if you were just thinking about it sort of off the top of your head, you'd say, oh, it's the same thing. 12% in a year, 6% in a half a year. It's the same thing I'm not going to worry about. But somebody who has a little bit of Asperger syndrome is going to pay attention to the details, and they're going to realize that it's not the same. What's the difference? What's the difference between 12% in a year and 6% per half year? So put on your Asperger's hats. Yeah.
With the 6%, the first time you'll have it after,
right.
It gets compounded, and then it gets compounded.
Right.
Right. Slow next time.
That's right. So, right? Everyone agree? So you leave the money in that you got at the end of the 6 months. You're going to have a little bit more at the end of the year, right? So 6% per year compounded is not the same as 12% per year. Right? It's different. So, I guess the moral of the story is go Asperger's. But, anyway, that's probably why I'm not going to be in finance. But anyway, so, all right, so let's play that a little bit more. So, which is better? 6% every half year, or 3% every quarter. 3% every quarter is better, right? Which is better, 3% every quarter or 1% per month? 1% per month. Which is better if we divide it up into days or months? So we say the words they use are when you say every half year, it's compounding semi-annually. Biannually means compounding every 2 years, but semi-annually means every 6 months. Okay? Or compounding quarterly. Or compounding monthly. That's better, right? Or compounding every day is better than monthly. Or compounding every hour, right, is better, right? Now it's not going to be a lot different, right? It's only going to be a little bit different, but it's better. Okay, so let's go back to, suppose we do 12%, but we say compounded monthly. And we're doing it for t equals 5 years. Okay, compounded monthly. Okay? Okay, so how do we figure out how much the future value is in this case? So we do the following. We're good. So the question is, what is the future value? Okay, so how do we figure this out? So the future value is going to be, okay, what we do is we make the compounding period not a year, but a month. So we're going to be compounding every month, so we just treat it, we think about it per month. But if we do that, we have to change the interest rate, right? Because we're not getting 12% every month, although that would be nice, but we're not, right? If we do it monthly, how much interest do we get per month? 1%, right? That's the equivalent of 12% per year is 1% per month, right? So we have to change the interest rate, right? We don't use R anymore, right? Because R is expressed as the interest rate per year. I said that at the beginning. The interest rate R is per year. So that's what R stands for. So we don't want to use R. So after 1 month, so after 1 month, the question is, what is it worth? So it's the present value, right? It's what we put in, times 1 plus R, but not R. R divided by 12. Right? It's 1%, not 12%. Right? So it's R divided by 12. Remember, that's what it's worth. Now what's it worth after the second month? So the future value is going to be the new present value, which is this. So this part is going to go into the new present value, right? This, I guess we should call that PV0. So it's going to be this whole thing, PV0, 1 plus R over 12. And then that's our new present value, and then we have to multiply that times 1 plus R over 12. Right? And then what about after the third month? Then it's going to be 1 plus R over 12 again, so it's going to be this thing to the third, right? Right? And then how many times do we have to do this? We're going to do it for 5 years. We're going to do it 12 times per year. So we're going to do it 5 times 12. Right? 5 years. 12 times each year is 5 times 12. So this is going to be, so the future value, this is after the after the second month, after the second month, and after the 60th month, the future value is going to be the present value, 1 plus R over 12 to the 60th, right? But let's write it out as 5 times 12, right? Because that's where we got the 60, right? Okay? Everybody agree with that? Okay, now, what if we compounded it quarterly? would be different about this? Well, this would not be r over 12 anymore. It would be r over 4. And this would not be 5 times 12 anymore. It would be 5 times 4. Right? And what happens if we compounded it monthly? Just did monthly. What happens if we did it weekly? And then what would happen? Then this wouldn't be r over 12 anymore. The interest rate would have to be the interest rate per week. So r is the interest rate per year. To get the interest rate per week, we'd have to divide by 52. So this would be 52, right? And this wouldn't be 12 anymore. That was 12 times per year, but that would be 52 times a year. So this would be 52. Right? Okay? So what's the general formula? Let's say M stands for the number of times per year that we're going to compound it. So it could be 12, or it could be, what else did we use? Weekly, could be 52, or it could be something else, could be quarterly, could be 4, right? So M is the number of compounding periods per year. Right? Everybody agree with that? Okay, so let's write it out in terms of M and in terms of T. Let's not use 5 years necessarily. Let's say it's going to be any T years. So what's our final formula look like? FV equals PV0, we'll just use PV. PV0, which is just PV. 1 plus what? R is given, so we still need the R. Over what? M. Right, it's R over M. Raised to the what? This is T, and this is M, right? So let's write it M, T. Okay, so that's a more general formula, right? That's if we allow ourselves to compound different number of times per year. The other formula was compounding once a year, right? But this allows us to compound as many times as we want per year. Can everybody read that? PV times 1 plus R over M, MT. If we did it right, then that should be correct. Okay? So that's a formula where we allow M to be something other than 1. Okay? Now they also use a different symbol for this. The interest, that's the interest rate per period, right? Right? So it could be the interest rate per month, or it could be the interest rate per week. Right? So they use I for that. I equals R over M. So you could replace that by I. Okay? So you'll see it both ways. You'll see it this way, or you'll see it PV 1 plus I MT. Okay, so I is just, as long as you know what I is, then that makes sense. Okay? Okay, so that's, now the question is, the last question is, what happens if we let M get bigger and bigger? Right? We said we could start with doing it every half year. That's M equals 2. Right? That's called biannually. No, semi-annually. Sorry, that's called semi-annually. And what happens if, and then we said, oh, what about quarterly? So that was M equals 4. Then we said monthly, that was M equals 12. Then we said daily, that's M equals 365. And then we said, what about if we we're able to do it every hour, you could say, what about if we're able to do it every minute? Right? Now, the difference between doing it every day and doing it every hour is not going to be very much money. Right? It's only going to be, a tiny amount, but it's going to be something. So compounding it daily is a little bit worse than compounding it by hour, but not much worse. Okay? But we could ask, what happens if we just let m get larger and larger? That's kind of like a calculus question. Calculus is what we're going to learn next, and that's when you look at what's called the limit as something gets bigger and bigger. So like that's, for example, if you're looking at a graph, let's say, let's say this one. This is EC. Y equals 1 over x. Okay, so what does that graph look like? We could ask. So you could put in 1, you could put in 2, you could put 3, 4, 5. 1, 2, 3, 4, 5. Okay, so but when you put in 1 into here, you get 1 out. Right? Let's make that a little bit higher. I'll put 1 up here. They put in 1 on they're not the same scales. Okay, when you put in 1, you get 1. When you put in 2, you get what? 1/2. When you put in 3, you get what? 1/3. When you put in 4, you get what? 1/4. So it looks like this. Okay? So we could say, well, what happens as